Okay, let's start today's training. Hello everyone. Today's training is about the after class exercise for the 11 days. So if you have any questions, you can mention it in the chat. So I will answer you. Let's start for the first day's exercise. In first days, we need to configure and clear the PLC code for the LX5V PLC. So I think it's very easy. Let's show it in a video here. So the first thing is we need to connect the PLC to our software, and then we click the PLC encryption tool and choose PLC code. And first we need to set the PLC code. The identical code format is 8-bit. You can use numbers or characters. After you enter the password for twice and click set, you will set the PLC code. And then we can see we can not download the PLC project directly unless we set the project code. If the both code is the same, you can download it successfully. And please remember the code you set because there are no other way to clear this PLC code. So you please do remember the code. And we will need the same code to clear the PLC code. As you can see, we need to check the PLC code option and enter the same code again. We set and click clear code password. And then the PLC code will be reset. This is the only way, so you must be careful to set the PLC code. Okay, I think we can move to the exercise for day 2. For day 2, I received many types to make the required to use X2 high-speed counter and set the D0 to 100 when the counter value reach 10. There are many ways, but here we mentioned we need to use the high-speed counter interrupter. So let's see the program. Here we use the PLC instruction DHSCS. So when the value of C C237 is equal to 10. So you will trigger I10 here. So this is the I10, the subroutine project. And then he will set the value of D0 to as 100. Okay, let's see it in the video. After we download this project to the PLC and in the monitor mode, and then as you can see, when the X2 C237 is the register for M2. Here. Hello, welcome to our training. And let's see it. Counter. For the high speed counter, just one phase. You can see it, X2. So we need to use C237. As you can see, C237. And for I10 here, it's also for the high speed counter interrupter pointer. So this is why we used I10 here. And with the value increased for C37 to 7 to 10. So you can see this subroutine instruction triggered. So it will from D0 will from 0 to 100. We can see it again. Yes, from 0 to 10 to 100. Okay, of course, there are many other code can achieve the same requirement. So this is just an example. Do you have any questions about the day 2's exercise? You can double click here and then you can enter item here. Can you show for example? Sorry, for the moment we don't have the X5V item, but I can show you directly. For the X5V, the first we need to create a new interrupt and set the type for the high-speed counter interrupter and choose which which channel we use. For here, for if we use X2, so we use HSC2 here. Yes, for the PLC code, it's the same for LX 5V and 3V. It's also the same. And then we can compare the value we need. For here, we need to 10 and set the priority. The small value will be higher priority. So you can see it's 0, 10 here. And then we can enter the program we need. For example, SM100. And the set 120. Okay, so you can set another program here to meet your requirement and just use this. So you can do the same in LX 5V. This setting means when the value of HSC2 is equal to 10, it will trigger this interrupt subroutine. Okay, let's move on to the day 3 exercise. For day 3, we need to use PLS Y2 instruction, a PLSR2 instruction to send multi-segment pass. So in the first part, we need to, the first parameter for the PLSR2 instruction is the start address for the setting. And the second is for the pass output. And the third is for the direction. Yes, as you can see it here. And we need to set many parameters here. The first, we need to set how many segments we need. And then we set from the third address. It will start for the parameter for the first segment. So here, as we requirement here, the first segment the frequency is 20,000 Hertz. So we set this value to D2. And the number of paths, 40,000 So we set the value to D4, and then we set the waiting time is 2 seconds. So we need to set D6 here. I will show you it in the PP presentation. That's 3. Yes. The waiting condition, we set time. So the D6, we need to set it as 1. D6 as 1. And because we use it as time, so it's a constant. So the D7, we also set it as 1. And for the D8, we set the value of time. The unit is milliseconds, so we set it 2 seconds is 200 2000 milliseconds here. So D8 is 200. And it's also the same for the second segment. Here, the frequency is 30,000 hertz. So we set it to D12. And the number of pulse is 60,000. So we set it to the D14. And then the waiting signal is M7. So here the D16 for M registers. The waiting signal we set is on valid. So we set it as 2. And we use M registers. So the D17, we set it as 1 for M registers. And M7, so we set S18 as 7. And the last segment also enter the frequency and the pulse, the number of pulse. And there are no waiting conditions, so we just set it as 0 for D26. Okay, so we can trigger M22 to send pulse in M1, in M0, and the direction signal is M1. Okay, let's see this example. When we trigger M22, it will send output pulse for the first segment, and then waiting 2 minutes, 2 seconds, and it will output another the second segment, and then we need to trigger M7. So it will output the last segment pulse. Can you see my screen? No. Oh, sorry, I just stopped the share. So we can see it again. In the first part, we need to trigger M22 to send the first segment pulse. and then you will wait for 2 seconds and plus the second pause. And then we need to trigger M7 to output the last segment pause. Okay, can you understand these instructions? How we set the parameters for the multi-segment pause? From the after class exercise, this exercise is easy for many people. And some I think it's just careless to set the wrong parameters here. For example, we need to use M7 and it sets another M registers. And so we need to be more careful. Okay, next can move to the exercise for day 4. Day 4's exercise is also easy. It's just to use some floating point instruction to calculate the uh, the circumference for the cycle. And here we use the pi as 3.14159. So we can see it in the program. It's easy to know, so we need to write the radius and pass it and use DEMUL instruction to get the diameter for the circle. And then we also use the same instruction to calculate the curve circumference of the cycle. So this is the total instructions we need to finish the day 4's instruction, the day 4's after class exercise. Of course, you can also use the D registers here and enter the value by yourself. Let's move to the after class for day 5. Day 5. So Okay, let's see this. The first, we need to reset the LX3V4 AD module. And then after finish the reset, we need to set the channel for voltage. And then we need to set the offset and the gain parameter. The first, we need to prohibit the offset and the gain adjust, and then set the value we need to meet this range. The input range is 0 to 5 volt, and the output, the range is 0 to 200. So we can see it in our HMI program. We need to set the value of gain is 25,000, and the offset value is 0. So here we set BFF24 as 25,000 and 0 for the offset value BFM23. And then we need to set the value of BFM22 as 3. So we can convert the value we set, and then we need to set BFM21 as 2 to finish the offset, the adjust. Okay, let's see it in the video. Trigger M2 to start the offset and again adjust. And set all these parameters. And finally, we can get the right, okay. Okay, for here, it's also the same for here. After we set the offset and the gain value, and set BFM21 as K2. So we finish the offset and again adjust, and then we can get the value from from the BFF9. I think we can use this video here. Yes, we can get the value from BFF9 and also for the BFF5. Okay, let's move to the exercise for day 7 and day 6. For day 6 is also very easy instruction here, only 2 lines instructions. So the first we the exercise is for the BD board. So the first things we need to enable the BD board by the RS instruction, RST instruction here. For the AV here. As you can see it here, the first we need to use RST instruction to make the corresponding channel for the voltage input mode. And then we can get the digital value from the corresponding channel. So here is for the channel 1. And once we get the value, and if we want to make some adjustment, we can use div instruction here directly for here. We need to the BD board gets the input range is for reach the 5-volt signal in channel 1 and guess the value is 100. If we don't make any adjustment, 5-volt signal will get the 1000 digital output here. So if we want to get as 100 here, not 1000, so we need to use div instructions to divide the value of D8112, divided it by 10, and get the new value which we need. As you can see it in this video. Let's move to the day 7 after class exercise here. Many people made some mistakes in this exercise. Some people, I think, is a little careless because the unit here is 0.1 degrees Celsius. So if the target value we need to set is 20 degrees Celsius, we need to set the value as 500, not just 50. And then we can also set the of the self-turning bias and the output limit, output range here. The range is from 0 to 1000. So these two parameters is for the output range. And then here, additionally, when the temperature is below 40 degrees Celsius, the Y10 is on. So the arm mode we need to set here is 2, not 1 in the demo I provide. The demo is the high temperature alarm, and here now we use is the low temperature alarm. So as you can see it here, for the 68, we need to set it as 2 for lower limit, but not set as 1 for upper limit. So in this form, the Y and also use D40 here. .44. And when the alarm 1 is occurred, so it will set on for the bit 4 of the BFM 44. So here I transfer BFM 44 to D44 and get the state of the 4th bit of D44 here to trigger Y10 here, reset. And other things for the parameter, model bus parameters for LX5V, we set it as here. The PLC as model bus master. So we set it here as 0 and choose model bus RTU. And here we use J-type sensor. So we also need to oh sorry, here is not here. It's for here. Not a model bus. Just station number is 3. So we need to set the first parameter for TO instruction is K3 here, not K0. And if we need to set the sensor we use, we need to refer to this. For here, type J is 1. So we need to set the BFM 0 as H0001. Only the first channel we used type J. And also you can set other 3 channel as other number here. For example, A, it means you didn't use this channel. Okay, do you have any questions about the LX3V for LTC demo module? Many people made some mistakes here for the alarm. Use the wrong parameter to still use the higher limit alarm. So when the temperature is over 40 degrees Celsius, the white 10 will be on. So here we need to set it. Set this parameter as 2. Okay, let's move to the reading mode for LX3V2WT module. If we use the varying mode, the first things we need to make the celebration. So we need to connect the load cell to the module and put nothing on the load cell, and then triggered M1 to set the here wiring module. First, we need to set BFM8 as 1 when there is nothing weight on the load cell. And then we add a send weight on the load cell and write the current weight to the BFM23. And then we set BFM8 as 2 to finish the calibrating weight. This is the first step for here, calibration. And then we can get the value from BFM 16, but it's the gross weight. And if we want to get the net weight, so we need to set tail weight first. And put the package on the load cell, and then we set BFM6 as 1 to set the tail weight value. And when we want to get the net weight, we need to set BFM7 as 1. And then we can get the net weight from the BFM 16. As this example shows, calibration first, and then get the gross weight. When we need to get the net weight, first we need to set the tail weight, and then triggered M4 to set BFM7 as 1, and then we will get the net weight from here. Okay, let's move to the exercise 8-9. This exercise is for the Modbus TCP communication. So as we can see it, the video, the first we need to set the PLC parameters, such as the PLC IP address, and then we set the SNAT configuration parameter. For here, we set the communication protocol and operating mode. Just want to mention something. For if the PLC operating mode is for a client side, you can add maximum number is 6 6 Modbus TCP client side and set the server ID, the target IP, and also the target port. For Modbus TCP, the port is 502. And then we also to set the SOC and TCP instructions parameters for the function code and the starting address, the length, and the registers we save the data or send the data to other device. And triggered M1, M0 to create a socket connect. And then use SOC and TCP instruction to write and read the bit address and word address. So here I use Modbus slave simulator to show how the PLC work with Modbus TCP protocol. The two types of register, the bit register and word register. After we connect the PC to the PLC, so now we can write the value and read the value from the simulator. You can see these registers 4104 is on and off. And for the word address, we can also set the value and the read value. Okay, for this demo, I will share it in the chat. And for the exercise day 10 is for the Modbus RTU protocol and the PLC as the Modbus master. So here, if we use LX5V, it will convenient to set the communication parameters. We just need to set it here. As I just said, PLC as Modbus master. So the station number here is 0. Choose the Modbus RTU and the boundary rate, stop bit, and the priority we need. And so here you can see the data bit, we cannot make the modification. turned on after same time. List special registers for the M9. That's 9 here. Let's see the register S9. S9 is the connection error. So do you try to use the same way for like use the Modbus slave simulator or connect a certain device? As you can see here, if the program is run properly, there are no error occurs. So you already use Modbus slave this software. If so, I think you can provide a video and then I will check. And I think you can also use the same program. Do you make any change in the program? And also the target ID IP here is the PC's IP. So here the PC's IP address is this. I'll just follow there. So I think you need to set the correct IP address for the PC to use this address, IP address. Okay, so we will continue to focus this issue after the training. And if we use LX 3V PLC, so we need to set the communication parameters by the instruction. As we can see it, this example, the first, we need to set the value of D8126 as 20. To set PLC as PLC Modbus master, and then set the value of D8120 to set the communication parameters. And the third thing we need to set is also the same for the LX5V, just the IS instructions parameters. The high byte is for the slave station number, and the lower byte is for the function code. And also set the length. And after that, we can use IS instruction and the corresponding function code to read and write the word address and the bit address. So here I think I made some mistake. For some device, there are requirements for the communication parameters. It will not always fit to all the device. So LX5V. Okay. For LX5V, it's also the same part to use IS instruction and set these parameters. The only difference is to set the PLC communication settings. So it's also here to set the COM1 or COM2, which depends on your needs. Enable it and set the communication parameters you need. Choose Modbus RTU protocol. And it depends on the PLC as Modbus master or slave. If PLC is master, so the station number is 0. And if it's slave, so the corresponding slave address here, you need to set here. But now the PLC has the Modbus slave, and the slave station number is 5. Okay, the rest is the same to use IS instruction. Yes, so you just set the station number as 0. Which series of PLC you use? LX5V or LX3V? Oh, 5V. Just as I just mentioned, set the parameter. Choose RTU. And the station number is 0. 0 is for the master station. Okay, let's move to the last after class exercise. For here, the last exercise is for the module LX3V4PG to output the pulse. LX3V or 5V? Or 5V. You can download the program here. It's just both contains PLC as master or slave. You can download it from our support center. Just choose this PLC LX5V series and mod demo, and then you can find it. Which device you connect to the PLC? Both is the LX, just two PLC and two LX5V PLC, right? To PC. I think you can have some, you can provide a video here because and which parameter you set. Also here is also a demo for LX5V. And it use the parameter settings. And they can communicate with Modbus slave. I think you can provide a video so we can share. Okay, I will provide to you this demo. It's also other channel from Vietnam to make this demo. And you can have a try. If you have any questions, you can provide a video and I will check. This instruction is not necessary if you set the parameters by the menu I just mentioned. And let's move to the LX4PG module. This module outputs the pulse to the server. So let's see it in the program. The first, we need to set the value of BFM2425 to setting the running mode. And we also need to set the speed, both the operating speed or jog speed, they are different. And then we can also get the module state from BFM28. And if we use the module for the single speed position, we need to set the position we want to get. And we can also get the current position from BFM26. And here I map the M100 to M116 to the BFM. So if I triggered M104 for this video, for this module, it means 24. Or 25 here. So if we triggered the bit 4 of BFM25 like here, we triggered M104 and the module will running in the jog mode. Let's see it. First, we set the speed for the both mode, jog mode and the single speed mode. And set the position for the single position mode, single speed position mode. And now, before we triggered M104 to make the module output the pulse, and we can see that now the position is 300,000. And now I triggered M104. You can see the position is changed. And also the opposite direction. Just be careful, these 3 bits cannot be on the same time, at the same time. Otherwise, it will output the pulse in the first state we triggered. And then for the single speed positioning, we can see the first time I triggered M108, the position doesn't change because the position we set before is just 100,000, and we use the absolute position mode. So I triggered M108, the position doesn't change. And if I triggered M107 and to make the mode running in the relative position mode, and now we can see the position is changed from 100,000 to 200,000. and we can also trigger it. Check check the M108 again and return the mode running in the absolute position mode. You can see the value is also from 200,000 to 100,000. This is the difference between the relative position, and the absolute position. And if you use the mode for the jog mode, you cannot trigger the M107 to make the module in the relative position mode. Otherwise, the module will not output any impulse. Okay, this is all the exercise we need to finish for the 11 days. If you can finish it by yourself, I think you can pass the final exam easily. And the final exam will take place on the Wednesday to the Friday. So please arrange your time to attend the final exam. Okay, do you have any other questions for this after class exercise? If you have any questions, you can also leave your message in our chat group. And our team will answer them. Okay, if you don't have any other questions for the moment, today's training will be finished. Thank you for your all attend. Please do remember to attend our final exam and hand in the after class exercise in time. Wish you to pass the final exam successfully. Okay, the last training will be finished today. So we will arrange another training for the next stage, and please pay attention for the message from your sales manager, and we will inform you if there are any news. We will inform you in time. So thank you for your attendance. You can also just hand in your exercise as soon as possible. So I think the last date is on this Friday, because at that time the final exam also finished. Okay, goodbye to you all. Bye bye.